Alrighty, welcome back to Fun Maths. Today we're looking at constant rates of change. So as we sort of alluded to in the previous video, it says here a function that is linear will have a constant rate of change. And that particular rate of change is simply the gradient of the graph. And then if you're given appropriate information, that rate can be calculated from the graph of the function, or you might be able to simply read it off the graph if it is stated. So here's an example of a constant rate of change. Oh, cool, it's a car, and it says it's traveling between two cities. Cool, Copperhunga and Charlie Gum. There's a distance between those, which is 150 kilometers, and it takes 2 hours to travel between those two towns, which is 120 minutes. Perfect. It says assuming the car travels at a constant speed, draw a time or distance time graph and calculate the speed. So again, with these particular examples, in the real world, we know that there are traffic lights and other traffic, and you might have to stop at a stop sign, things like that. Again, this particular example just assumes like the car is going at constant speed, there's no interruptions or anything for the 150 kilometers. So I acknowledge straight away that there are some real world implications there, but for the sake of this, everything's perfect, and the car's traveling at the constant speed. So we set up our distance time graph. Time goes along the x-axis, distance goes on the y-axis. Obviously we're dealing in kilometers and we're dealing with minutes. So in the 2 hours, so 120 minutes, it takes the car 150 kilometers. Okay, so we're going to get to that particular spot. I'm obviously saying from the origin, where you've traveled no distance, and that's at the time 0. Obviously creating a straight line between each of those particular points. Once you've got that, you can see the rule or the gradient of this here is it's got a rise of 150 over the run of 120. So that's where the gradient 150 over 120 comes from, multiplied by the time here. 150 over 120 can be simplified down to 5 over 4. So the equation for this straight line would be 5 over 4t. Perfect. Now what they're saying here is that the ratio between each of these, between xy and yo versus BA and AO, is 5 over 4. Yep, that's the gradient. Now it says the gradient of the graph gives the speed in kilometers per minute. Therefore, the speed of the car is 5 over 4 kilometers per minute. Cool, because that's the gradient. Yep. It says this speed may be expressed in kilometers per hour. So if you've got kilometers per minute, you need to multiply that by 60 to change it into kilometers per hour. So 5 over 4 multiplied by 60 gives us the speed of 75 kilometers per hour. Indeed, if you look at the graph here, in an hour, which is 60 minutes, you can see the distance travelled would be 75, or 75 kilometers per hour is the speed. Yep, so that all sums it up very nicely there. Alrighty, next example. Oh, cool, this is the car example. Another car example. These 3 cars are driven over a 2 kilometer straight track. Do need to know that 2 kilometers is the same as 2,000 meters. And also it says they are all going from point A to point B, and each car is traveling at a constant speed. It is not a race, however. Yep, so they're not trying to compete with each other. They are just traveling at a constant speed. There's some additional information. They're telling us that the speed of car Y is twice that of car X, and they're telling us that the speed of car Z is half that of car X. So to illustrate this situation with a distance time graph, and they're telling us assume that car X travels at 1 kilometer per minute. Alrighty, so first one that we want to sketch on the distance time graph is car X. 1 kilometer per minute is the same as 2 kilometers in 2 minutes. So 2 minutes is 120 seconds. So again, if we wanted to find out that 2 kilometers, that's going to take 2 minutes, which is 120 seconds. So we can put that point on there. That's how long it's going to take for car X to get to 2,000 meters, which is 2 kilometers. It's going constant speed, so we can draw that from the origin at the start there. If car Y is going twice that speed of car X, if car X is going 1 kilometer per minute, then car Y is going to be going 2 kilometers in a minute. Yep, so 1 minute is 60 seconds, that 2 kilometers is 2,000 meters, that's how far that's going to be going in that time. Last but not least, it says the speed of car Z is half that of car X. So if car X is going 1 kilometer per minute, car Z is going to be going half a kilometer in a minute, or the other way, it's going to be going 2 kilometers it's going half the speed. Yep. So it's going to be going 1 kilometer in 2 minutes, or it's going to be going 2 kilometers in 4 minutes, which is 24 seconds. However you need to think about it, it's up to you. But we can get that particular position there for that. Drawing those straight lines, we can illustrate this particular situation. This goes on and talks about some other areas where you have straight line graphs representing a rate, and the two examples they've given here is petrol consumption of a car. However, as the book does illustrate or talk about, they're making some large assumptions there about the nature of the amount of petrol being used for the kilometres that car has travelled. And also exchange rates of currency can also be represented using the gradient of a graph, a straight line graph. Thank you very much for listening. Bye for now.